AP Calculus, BC, Unit 5, Day 5, Office Hours. These are the answers. Hopefully you've tried all these problems. Hopefully you checked your answers already. Try to put them online for you guys to check, but here they are again real quick. Pause the video if you need to. Here's a few more. We're trying to combine the logs in the answers, so using log rules. Pause the video if you need to. So 14, no absolute values for the final answer. They should be in your work. All right. So, all the different techniques are fair game. So you should always consider U-Substitution, because if it works, it's way easy and actually gives you the right answer. So U-Substitution works here. All right, we got dx over dx. So that's going to be 1/3 du over u, which is going to be 1/3 natural log of the absolute value of u plus c, which is going to be 1/3 natural log of the absolute value of x cubed plus 2 plus c, and that's it. Absolute value should be in your final answer. Okay, number 2, U-Substitution is not going to work, but neither is partial fractions. This is an inverse tangent, right? This is something squared, so it's going to be 2x. We will use U-Substitution, but to make it fit the inverse tangent. So du equals 2 dx, don't need the 2. So this is going to be 1/2 du over 1 plus u squared, which is 1/2 inverse tangent of u plus c, which is 1/2 inverse tangent of 2x plus c. There you go. Number 3, u equals 1 minus 9x to the 4th. I mean, almost looks like it'd be inverse sine, but nope. Regular old U-Substitution. Because we get that x cubed dx. Don't want the 36. Divide by the negative 36. So this is going to be negative 1 over 36 du over the square root of u, which is not natural log. It's a power rule problem. So you're going to increase it by 1 and divide by the new exponent multiplied by the reciprocal plus c. It's going to be negative 1/18 square root of 1 minus 9x to the 4th plus c. There you go. Number 4, you know, it's fine to try, at least in your head, things. Negative 36x cubed dx, but that doesn't work because we need x dx. So then you're like, oh, well, maybe this is inverse sine with u equal to 3x and du equal to 3 dx. Well, it should be squared because it was about 6x. That wasn't going to work either, but I forgot the square. So don't want the 6. So we're going to do 1/6 du over the square root of 1 minus u squared. 1/6 inverse sine of u plus c. 1/6 inverse sine of parentheses 3x squared plus c. Five. 5 is not secant squared. We're going the wrong way. We don't have an antiderivative for tangent. So what you should do, sometimes with trig, is rewrite it in terms of other trig. And now this is a U-substitution. Let's make the denominator our U, and then du equals negative sine x dx. Don't want the negative. So we get negative du over u, negative natural log of the absolute value of u plus c, negative natural log of the absolute value of cosine x plus c. There you go. That's how you do it. 6, if we pick the whole denominator as u, it's not going to work. It's going to be x cubed. So we think, well, maybe it's inverse tangent, but there needs to be a 1 here. So we're going to factor 25 out of everything in the denominator, so there's a 1 there, but then that also means that x to the 4th is divided by 25 now, which is fine. This is got to be something squared. It's going to be x squared over 5. So that's going to be our u. U equals x squared over 5. And du equals 2/5 x dx. Don't want the 2/5, so I multiply both sides by 5 halves. So now I have 1/25 already, and now I have another 5 halves, integral of du over 1 plus u squared. So that's going to be 1/10 inverse tangent of u plus c. That will be 1/10 inverse tangent of x squared over 5 plus c. All right. All old techniques, but sometimes that doesn't work. You got to do partial fractions. So here, if you try to use, it doesn't work. None of the other special patterns fit. So we're going to factor this. Now, the degree of the numerator has to be less than the denominator use partial fractions. So we're going to get a over 3x plus b over x plus 3. I'm going to multiply 3 by the least common denominator. And we can plug 0 in. And then we'd get 3 equals 3a, a equals 1. Then we plug negative 3 in. Get negative 15, negative 12 equals negative 9b. So b equals 4/3, positive. So we're going to rewrite it. Integral of dx over 3x plus 4/3 dx over x plus 3. This is going to be 1/3 natural log of the absolute value of x plus 4/3 natural log of the absolute value of x plus 3 plus c. That's an answer, but I need you to go further. Let's combine them. We could just leave the 1/3 in front of both of them and do natural log of x. We got to bring the 4 in at least. So if they have the same coefficient in front, you can just put that in front of the new one. X plus 3 to the 4th plus c. This is all inside one. We don't need absolute values around this anymore because it's being raised to an even power, so that will for sure make it positive. So that's another answer. We could bring the 1/3 inside and write it as like the cube root of the absolute value of x times x plus 3 to the 4th power plus c. I mean, that's another possible answer. All right, let's keep going. Do our other methods work here? No. So x plus 2x minus 2. Let's try partial fractions. So it's going to be a over x plus 2 plus b over x minus 2 dx. And then going to multiply 3 by the least common denominator. We're going to plug We plug negative 2 in. It's going to be negative 12 equals negative 4a. A equals 3. We plug 2 in. That's going to be negative 4 equals 4b. B equals negative 1. So we rewrite it. 3 dx over x plus 2 minus 1 dx over x minus 2 equals 3 natural log absolute value of x plus 2 minus natural log absolute value of x minus 2 plus c. So, I mean, that's an answer. Let's try and combine it. So we bring the 3 inside, natural log of x plus 2 cubed divided by absolute value of x minus 2 plus c. We could put this all in one big absolute value. Seems a little nicer, maybe. So, something like that. All right. You guys getting good at these? Giving you lots of practice. Okay. X plus 2, x plus 2. This is a repeated root, right? X plus 2 squared. So special case, we have a over x plus 2 and b over x plus 2 squared. So if you have a repeated root, you do it with just one power and then with the second power. Multiply 3 by the least common denominator. What always happens with these is that there's one variable you're not going to be able to get rid of. So we got to do it differently. But we could get rid of the a and get b. But then we can't get rid of b to find a. So I would say, well, let's just plug 3 in. So we get our, I'm going to plug negative 1 actually. Negative 1. So we get a nice 1a here. And replace this with 3. So we have 5 equals a plus 3. So a equals 2. So we're going to rewrite it. 2 dx over x plus 2 plus 3 dx over x plus 2 squared. Now this is negative power. This is x plus 2 to the negative 2. All right, so that's power rule. This is going to be 2 natural log of the absolute value of x plus 2 plus 3 x plus 2 to the negative 1 divided by negative 1 plus c. I don't want negative exponents for final answer, so it's going to be 2 natural log of the absolute value of x plus 2 minus 3 over x plus 2 plus c. All right. So that's how you do repeated roots. Number 10, x plus 4, x plus 4, another repeated root. So equals a over x plus 4 plus b over x plus 4 squared dx. Multiply 3 by the least common denominator, 3x plus 17 equals a x plus 4 plus b. So we plug negative 4 in. So you do have to find whichever one you can first. This is going to be negative 12. This is going to be 5 equals b. So then I would plug in something, can't get rid of b, but plug something in that gives you a nice a, like 1a. So I'm going to plug negative 3 in. You plug whatever you want in other than negative 4. Anything will work. But certain things might make it easier. And then I'm going to plug 5 in for the b. And so I'm going to get a equals a plus 5. So a equals 3. So I'm going to rewrite it. 3 dx over x plus 4 plus 5 dx over x plus 4 squared. It's going to be a power rule. So we get 3 natural log the absolute value of x plus 4 plus 5 x plus 4 to the negative 1 divided by the new exponent plus c. So 3 natural log the absolute value of x plus 4 minus 5 over x plus 4 plus c. There you go. Now, next one. Looks like we're going to do partial fractions. So I think we can take a 2x out. We have an x squared plus 4 left over. You can't factor this, so we're just going to leave it and hope this works out. So this is going to be a over 2x plus b over x squared plus 4 dx. Multiply through by the least common denominator. Now we have a problem. We can't get rid of a. Whatever you plug in x will never equal 0. We could get rid of b, plug 0 in everywhere. So let's do that first. So 12 equals 4a, a equals 3. So I think we're going to need to take a strategy from the last two repeated roots problems. This isn't a repeated root. And plug the 3 in, and then plug whatever we want into b. I'm going to plug 1. And plug 1 in everywhere. So if I do that, I get 25 equals, this is going to be 5 times 15 plus 2b. So it's going to be 10 equals 2b. So it's going to be b equals 5. So we couldn't totally do the Heaviside approach for all of it. So we had to find a first, and then use the value of a to help you find b. So we rewrite this 3 dx over 2x plus 5 dx over x squared plus 4. Now this is interesting. This is going to be 3 halves, natural log of the absolute value of x. This is inverse tangent, but you got to make this a 1 first. So you're going to factor 4 out to make that a 1 first. And then this is going to be your u, x over 2. So u equals x over 2. So du equals 1/2 dx. I don't want the 1/2, so I'm going to multiply both sides by 2. So this is going to be plus 5/4 times 2 integral of du over u squared plus 1. It's going to be inverse tangent. Which means we're going to put an x over 2 in there. That's your final answer. So other strategies can pop in the middle of these. All right, these ones are telling you right away it's long division. You're gonna have to recognize these for your test. We cannot do partial fractions yet. The degree of the top is either bigger or equal to the bottom. We can't do it. So we got to start with long division. So we divide the first terms and then distribute. If you've done it right, the first term should cancel out. This time these guys cancel out too. We have 0. So we drop the next term down, which is 2. So we're done because once the degree of this is smaller than this, then we can't divide anymore. So this is the remainder. So what we have now is we have x plus 2 over x plus 4 dx. I think we're ready to integrate. So we get x squared over 2. It's 2 natural log of the absolute value of x plus 4 plus c. Done. All right. 13. We have to do long division. X to the 4th plus 0x cubed plus 1x squared plus 0x plus 3. So any missing terms you want to represent. And we're divided by x squared plus 0x plus 1. This will help everything line up really nice, which is you want. So x fourth divided by x squared is going to be x squared. This gives you x to the 4th plus 0x cubed plus 1x squared. Going to subtract, cancel, cancel, cancel. drop the next term down, drop the next term down. Once the degree of this is less than that, you're done. This is the remainder. So what we have now is we have x squared plus x plus 3 over x squared plus 1. Oh, that's 0x, so just 3 dx. So this is going to be x cubed over 3 plus 3 inverse tangent of x plus c. (14) c. X cubed minus 2x squared plus 2x minus 2 divided by x squared plus 0x plus 1. So it's going to be x cubed plus 0x squared plus 1x. We subtract. So we get negative 2x squared plus x. Drop the next term. Well, yeah, drop the next term down. And negative 2x squared divided by x squared is minus 2. So you get minus 2x squared plus 0x minus 2. Subtract. And it looks like the remainder is 0. Nice. Or did I make a mistake? Nope, there's an x right here. Seemed too good to be true. 0 remainder. Seems like I probably could have done it a different way. I wouldn't know how to do this partial fraction stuff. So we have x minus 2 plus x over x squared plus 1. Now I'm going to use U-substitution for this. U equals x squared plus 1. Du equals 2x dx. This is not inverse tangent. So this is going to be x squared over 2 minus 2x plus 1/2 du over u. Natural log of the absolute value of u. Plug the x's back in. I think I lost something somewhere. X squared. X squared plus 1. Where did I get that from? Okay, so now, by the way, this is always positive, which means our final answer really shouldn't have absolute values around anyone. It should be 1/2 natural log parentheses x squared plus 1, because that'll be positive no matter what. So absolute values are going to change it. So just use parentheses. Okay. One more. This is a big one. 6x to the 4th plus 9x cubed plus 0x squared plus 3x minus 18 over 6x squared plus 9x plus 0x. So we divide those, we get x squared, distribute, 6x to the 4th plus 18x cubed plus 0x squared. Subtract, get negative 9x cubed plus 0x squared. Drop the next term down, 3x. Divide again by 6x squared, so it's going to be negative 3/2 x. It's a little messy. I feel like I made a mistake. It should have just been 9. So that goes away. And we're done. This is the remainder. So what we get is we get x squared plus 3x minus 18 over 6x squared plus 9x dx. I don't know if factoring the top is going to help. The bottom, we take a 3x out. So I think we're gonna have to, we could get rid of the 3's. That makes life a little easier. But I think we're gonna have to do partial fractions here. So this is gonna be a over x plus b over 2x plus 3. So I got rid of the 3's. You can leave 3's in there. It should work out the same. Get slightly different numbers and stuff, but in the end it should be the same. So we're gonna multiply it by the least common denominator. Plug 0 in. Plug in negative 3 halves. And that goes away. So this is going to be minus 12 as negative 15 halves equals negative 3 halves. B equals 5. Okay, so now we're going to rewrite this as x squared. We write it separately, dx minus 2 dx over x plus 5 dx over 2x plus 3. So this is going to be x cubed over 3 minus 2 natural log of the absolute value of x plus 5 natural log of the absolute value of 2x plus 3. But chain rule is going to spit an extra 2 out, so we've got to divide by 2 plus c. So, and then we could combine these logs by bringing this inside, bringing this inside. Natural log of 2x plus 3 to the 5 halves. The one on the bottom, you can get rid of the absolute values because it's being squared now. Plus c. There you go. That's it. Hopefully you guys are getting good at this stuff.